In 1935, the German Air Ministry invited 4 aircraft companies to submit prototypes for a new single-seat fighter. The Luftwaffe was rearming in secret. Its existing fighters were biplanes, open cockpit machines that belonged to the previous decade. The specification called for a modern monoplane, fast, enclosed, armed, and fitted with retractable landing gear. 4 companies answered: Arado, Focke-Wulf, Heinkel, and a company from Augsburg that the ministry's most powerful official had spent 5 years trying to destroy. That company was Bayerische Flugzeugwerke. The designer was Willy Messerschmitt. The man trying to destroy him was Erhard Milch, State Secretary of the Reich Aviation Ministry, the second most powerful figure in German military aviation behind Hermann Göring himself. Milch had cancelled Messerschmitt's contracts, forced his company into bankruptcy, and openly favored every competitor in the industry. He had done all of this for one reason: a dead friend, a crashed prototype, and a designer who did not attend the crash site. The fighter Messerschmitt submitted to the competition would become the most produced fighter aircraft in history. The jet he built a decade later would become the first operational jet fighter ever flown in combat, and the regime he armed would destroy everything he built, including the man himself. Wilhelm Emil Messerschmitt was born on June 26, 1898 in Frankfurt am Main. His father, Baptist Ferdinand, was a wine merchant who moved the family to Bamberg in northern Bavaria when the boy was 8 years old. Bamberg was a textile town, quiet and provincial. It was also home to Friedrich Harth, an architect and glider enthusiast who was among the first Germans to build and fly sailplanes. Messerschmitt met him at the age of 13. The boy was already building model airplanes. Harth gave him something better: real gliders, real aerodynamics, and real flight. The two began collaborating on sailplane designs, each one designated with an S and a number. When Harth left for military service after the outbreak of the First World War in 1914, Messerschmitt stayed behind and continued work on the S-5 glider alone. He was 16 years old, designing and building aircraft by himself in a Bavarian workshop. In 1917, Messerschmitt was called into service. He was stationed at a military flight training school near Munich, where Harth also served. The two resumed their glider experiments the moment the war ended. In 1921, Harth flew their S-8 glider for 21 minutes without a motor. It was a world record for unpowered flight. Messerschmitt enrolled at the Munich Institute of Technology and graduated in 1923 with a degree in engineering. He founded his own aircraft company that same year in Bamberg. He was 25 years old. He had no capital to speak of, no military contracts, and no reputation beyond the glider community. He had a workshop, a degree, and an obsession with making things fly faster while weighing less. He called his approach Leichtbau, lightweight construction. The principle was simple: merge structural elements wherever possible. Combine the firewall, the engine mount, and the load-bearing frame into a single reinforced component. Every gram removed was a gram the engine did not need to carry. Every reduction in weight was an increase in speed, in climb rate, and in range. Messerschmitt pursued this principle with a rigor that bordered on recklessness. By the late 1920s, Messerschmitt was designing powered aircraft. He developed the M20, a single-engine, 10-seat transport for Deutsche Lufthansa, Germany's national airline. Lufthansa ordered 10 of them. The airline was controlled by a man named Erhard Milch. On February 26, 1928, test pilot Hans Hackmack took the M20 prototype on its maiden flight at Augsburg. The aircraft flew for 20 minutes without incident. Then, something at the trailing edge of the wing began to flap. Witnesses on the ground watched through binoculars. Hackmack emerged from the rear fuselage door and jumped. His parachute did not deploy in time. He was killed on impact. The investigation concluded that a piece of fabric had come loose. There was no structural failure. The aircraft could have been landed safely. Hackmack had panicked, likely remembering a near-fatal test flight weeks earlier. Nobody was directly responsible. But Hackmack had been Erhard Milch's personal friend and pilot. Milch was devastated. What made it worse was Messerschmitt's response. He did not attend the crash site. He expressed no personal sympathy. His reaction was clinical and detached, the response of an engineer who saw a dead pilot as a data point rather than a human being. Milch never forgave him. A second M20 crashed the following year, killing all 8 passengers and the pilot. Milch canceled every remaining Lufthansa order. Without the airline contracts, Bayerische Flugzeugwerke collapsed. Milch forced the company into bankruptcy in 1931. The most powerful man in German civil aviation had made it his personal mission to ensure that Willy Messerschmitt never built another aircraft. The bankruptcy should have ended everything. It did not. Germany's political landscape was shifting beneath the surface. In January 1933, the Nazi government took power. Hermann Göring established the Reich Aviation Ministry. Milch became its state secretary, and Germany began rearming in violation of the Treaty of Versailles. The aviation industry was suddenly flooded with contracts. New companies were founded, existing ones expanded. Bayerische Flugzeugwerke was resurrected in 1933, kept alive partly by the rearmament boom and partly by Messerschmitt's personal connections. He had cultivated friendships with senior Nazi party figures, including Rudolf Hess. Those friendships shielded him from Milch's hostility, at least enough to keep the company operating. Messerschmitt's first design for the relaunched company was the Bf 108 Typhoon, a 4-seat touring monoplane. It was fast, clean, and technically advanced. It demonstrated everything Messerschmitt believed about lightweight construction: low-wing monoplane, retractable landing gear, enclosed cockpit, and slotted flaps. The 108 won admiration across Europe and established Messerschmitt as a serious designer of modern aircraft. Then came the fighter competition. In early 1934, the RLM issued the requirement for a new single-seat interceptor to replace the Heinkel He-51 biplane. 3 companies received development contracts in February: Arado, Heinkel, and BFW. Focke-Wulf received its contract later. Each was asked to deliver 3 prototypes for evaluation. Messerschmitt, collaborating with chief designer Robert Lusser, incorporated every advanced feature he had proven on the Bf 108 into a smaller, more aggressive airframe. Low wing, retractable gear, enclosed canopy, and slotted leading-edge slats for low-speed handling. The competition took place at the Luftwaffe's test facility at Travemünde in early 1936. The Arado R-80 was eliminated early. The Focke-Wulf FW-159, a parasol wing design, was hopelessly outclassed. The real contest came down to 2 aircraft, the Heinkel He-112 and the Messerschmitt Bf 109. The He-112 was a beautiful aircraft, more refined and more conventional than the 109. Heinkel was the established name, and Milch openly favored it. But in the air, the 109 was faster and lighter. Messerschmitt's obsession with weight reduction had produced a machine that climbed quicker, dove harder, and rolled tighter than anything else at the field. The Bf 109 won the competition. Milch was overruled. The aircraft that the most powerful bureaucrat in German aviation had tried to prevent from existing became the backbone of the Luftwaffe. The Bf 109 entered combat for the first time during the Spanish Civil War. Germany sent a volunteer air unit called the Condor Legion to support Franco's nationalists, beginning in 1936. The first 109s arrived in Spain in early 1937. They outclassed every Republican fighter they encountered, including Soviet-supplied Polikarpov I-16 monoplanes that had previously dominated the skies over Madrid and the Ebro. Werner Mulders, a young pilot who had become one of Germany's most celebrated aces, developed new fighter tactics in the 109 over Spain. The old tight formation flying of the biplane era was discarded. Mulders introduced the Schwarm, a 4-aircraft formation with 2 pairs operating in a loose finger pattern that gave each pilot room to maneuver and mutual protection. The tactic became standard across every air force in the world within a decade. The Spanish campaign proved the design under fire. Speed, climb rate, and dive performance. The 109 delivered on every metric Messerschmitt had promised. In November 1937, a specially modified Bf 109 set the world landplane speed record at 379 mph. Messerschmitt used the record as proof that lightweight construction was not merely a theory. It was a competitive advantage measured in miles per hour. By September 1939, when Germany invaded Poland, the Bf 109 was the Luftwaffe's primary fighter. It swept the skies over Poland in days. Over France in 1940, it dominated again. Over the English Channel during the Battle of Britain, the 109 met its first serious opposition. The Supermarine Spitfire was marginally faster, more maneuverable in a sustained turn, and carried 8 machine guns. The 109's advantage was in the dive and at altitude. The two aircraft were closely matched. The decisive factor was not the machine, but the mission. The 109's fuel capacity gave it roughly 10 minutes of combat time over southern England before it had to turn for home. Messerschmitt's obsession with lightweight construction had produced a fighter with insufficient range for the strategic task it was being asked to perform. Over the Eastern Front, beginning in June 1941, the 109 regained total dominance. Soviet fighters in the opening months were older designs, poorly maintained, and flown by pilots with minimal training. German aces accumulated staggering kill counts. Erich Hartmann, who flew the Bf 109 exclusively, recorded 352 aerial victories, more than any fighter pilot in history. The 109 was the instrument of that record, but the instrument was aging. By 1943, the Bf 109 was being outperformed by newer Allied fighters on every front. The American P-51 Mustang was faster, longer-ranged, and better armed. The Soviet Lavochkin, La-5, and Yakovlev Yak-9 had closed the performance gap. The British Spitfire had evolved through multiple marks, each one more capable than the last. The 109 received more powerful engines and heavier armament with each successive variant, but the basic airframe dated to 1935. Messerschmitt was bolting improvements onto a structure that had reached its developmental ceiling. The Bf 109's narrow landing gear, a consequence of the original lightweight wing design, caused ground accidents throughout the war. Approximately 5% of all 109s built were destroyed in landing or takeoff incidents. The very design philosophy that made it fast in the air made it treacherous on the ground. In total, approximately 33,984 Bf 109s were built between 1936 and 1945, making it the most produced fighter aircraft in history. Additional hundreds were manufactured under license in Spain and Czechoslovakia after the war. The airframe that Milch had tried to kill before it was born outlived the regime that built it. But Messerschmitt was already looking beyond propellers. In 1938, the same year the company was renamed Messerschmitt AG in his honor, the RLM issued a development contract for a fighter powered by a new type of engine, not a piston engine driving a propeller, but a turbojet. This was a machine that compressed air, mixed it with fuel, ignited the mixture, and expelled the exhaust at high velocity to produce thrust. The concept was radical. The engineering was unproven. The engines did not yet exist in any reliable form. Messerschmitt's design team produced the initial concepts for what would become the Me-262 in late 1938. The first project drawings were submitted in June 1940. The airframe was elegant. A low-wing monoplane with 2 jet engines mounted in nacelles beneath the wings, tricycle landing gear, and a pressurized cockpit. The design anticipated speeds that no propeller-driven fighter could match. The problem was the engines. Both BMW and Junkers were developing turbojets, and both were failing. The BMW's 003 suffered repeated compressor blade failures. The Junkers Jumo 004, the engine that would ultimately power the 262, was so unreliable that its early prototypes disintegrated during testing. The airframe was ready, the engines were not. On April 18, 1941, the first Me-262 prototype took to the air. It flew on a conventional Junkers Jumo 210G piston engine mounted in the nose because the jet engines were not ready. The aircraft looked absurd, a sleek jet-age fuselage dragged through the sky by a propeller. But it flew. On July 18, 1942, the third prototype, the V3, made the first flight under jet power alone. Test pilot Fritz Wendel took it into the air from Leipheim Airfield. The aircraft reached speeds that left every piston engine fighter in the world behind. In May 1943, Adolf Galland, the Luftwaffe's general of fighters, flew the Me-262 for the first time. His reaction entered aviation legend. He described it as though an angel were pushing. He immediately grasped the strategic implication. A fighter that fast, deployed in sufficient numbers, could break the American daylight bombing campaign that was systematically destroying Germany's industrial base. He lobbied Hitler, Göring, and the RLM to put the Tu-62 into mass production as a fighter immediately. Hitler had other ideas. In November 1943, the Me-262 was demonstrated at the Insterburg Aviation Center. Hitler watched the aircraft fly and asked Göring a single question: "Can it carry bombs?" Göring told him it could carry 500 kilograms, possibly 1,000 in the future. Hitler seized on the answer. He declared that Me-262 would be used as a Schnell bomber, a fast bomber to repel the Allied invasion he knew was coming. A jet that could carry bombs across the English Channel faster than any interceptor could catch it. Galland was appalled. Speer protested. The Luftwaffe's fighter commanders argued that the Tu-62's value was in the air-to-air role, not as a makeshift bomber carrying a fraction of the payload a conventional bomber could deliver. Hitler refused to hear them. In the spring of 1944, he issued explicit orders that all Me-262 production be directed toward the bomber variant. Anyone who contradicted the order risked a charge of defeatism. The order created chaos. Engineers at Messerschmitt had to redesign hardpoints and modify the airframe for bomb racks the aircraft was never intended to carry. Production schedules were disrupted. The bomber variant performed poorly. The Tu-62 was designed for speed and altitude. Dropping bombs required level flight at low altitude, negating every advantage the jet possessed. Historians have debated for decades how much time Hitler's bomber directive actually cost. Some argue the true delay was only weeks because the Jumo 004 engines remained the critical bottleneck throughout. The average service life of a Jumo 004 in mid-1944 was approximately 25 hours. The engines burned through their turbine blades at an extraordinary rate. Even without Hitler's interference, mass production could not have begun meaningfully earlier because there were not enough engines that worked. But the directive was not the only political obstacle. As early as autumn 1940, Hitler had ordered all research and development projects deprioritized that could not deliver results within 1 year. The order was aimed at focusing industrial resources on winning the war quickly. Its effect was to delay the Me-262 by an estimated 2 years. The jet program lost time not because the engineering failed, but because the political leadership could not decide what it wanted the engineering to produce. In September 1944, Hitler finally rescinded the bomber order. By then, more than 100 Me-262 fighter airframes sat in factories without engines, waiting. As Jumo 004s trickled off the production line, the aircraft were completed and delivered to frontline units. The first operational unit, Erprobungskommando 262, had begun flying combat sorties in July 1944. On July 26, Lieutenant Alfred Schreiber shot down a British Mosquito, the first confirmed aerial victory by a jet fighter in history. When the Tu-62 fought as a fighter, it was devastating. 430 Mk-108 cannons in the nose could shred a B-17 Flying Fortress in a 2-second burst. A single round from the Mk-108 weighed 330 grams and detonated on impact with enough force to blow a wing off a heavy bomber. The Me-262's speed advantage over every Allied propeller fighter was roughly 120 mph. American escort pilots could not catch it in level flight. They could not pursue it in a climb. The only reliable tactic was to attack the Tu-62 during takeoff and landing. When its speed advantage vanished and its slow accelerating engines left it vulnerable, American fighter groups began dedicating entire squadrons to orbiting known Me-262 airfields, waiting for jets to slow down enough to be killed. In March 1945, Jagdverband 44, an elite unit commanded by Galland himself and staffed with Germany's most experienced aces, began operating the Me-262 from airfields in southern Germany. The unit shot down Allied bombers at a rate that alarmed American commanders. But by then, there were not enough jets, not enough fuel, not enough pilots, and not enough airfields that had not already been destroyed by Allied bombing. Approximately 1,430 Me-262s were produced. Fewer than 300 ever saw combat. The aircraft that could have changed the air war arrived too late in too few numbers, consumed by a leadership structure that could not stop arguing about what it was for. The factories that built both the 109 and the 262 ran on forced labor. In January 1943, Messerschmitt licensed an SS-owned company called DEST to manufacture Bf-109 parts at Flossenburg concentration camp. Messerschmitt provided technicians, raw materials, and tools. The SS provided prisoners. The arrangement was profitable for both parties. On August 17, 1943, the United States 8th Air Force launched the Schweinfurt-Regensburg mission. 146 B-17 bombers attacked Messerschmitt's Regensburg plant. The factory that had been producing 25 Bf-109s per day was shut down for 4 weeks. The Luftwaffe lost the output of an entire month's production in a single afternoon. Messerschmitt's response was to disperse. Production was partially relocated to the Gusen concentration camp in Austria. The average life expectancy of a prisoner at Gusen was 6 months. Inmates were forced to dig tunnels through solid rock so that aircraft production could continue underground, safe from Allied bombs. Many died performing that work. In February 1944, the Americans bombed Regensburg again during Big Week. By mid-1944, more than a third of the Bf-109 parts feeding the Regensburg assembly line originated in concentration camps. Only the final assembly took place at the factory. Willy Messerschmitt knew the arrangement required his company's direct participation, his engineers on site, his materials shipped to the camps. The production records exist. The history is documented. On May 8, 1945, Germany surrendered. The Allied occupation authorities seized the Messerschmitt factories. Willy Messerschmitt was arrested, tried for employing forced labor, and convicted. He spent 2 years in prison. When he emerged, Germany was forbidden from manufacturing aircraft. A 10-year moratorium imposed by the Allies prohibited all aviation production on German soil. The company that had built more fighter aircraft than any manufacturer in the war now needed something else to make. Messerschmitt rebuilt the Augsburg factories and turned them to civilian production. Prefabricated houses, sewing machines, and a 3-wheeled bubble car called the Kabinenroller. Designed by engineer Fritz Fend and produced under the Messerschmitt name, the KR-175 and its successor, the KR-200, had a hinged canopy that opened like a fighter cockpit, tandem seating arranged front to back, and a tiny single-cylinder engine behind the rear seat. The car looked exactly like what it was, an aircraft cockpit that had been bolted to 3 wheels by a company that was not allowed to build aircraft. The civilian ventures proved that Messerschmitt's talents were restricted to aviation. The sewing machines were poorly made and sold in small numbers. The prefab housing business stalled. The bubble car was a curiosity, not a commercial foundation. It sold modestly to a post-war German public that needed affordable transportation, but it was never profitable enough to sustain the company. By 1956, the company was nearly bankrupt and deeply in debt to the Bavarian and federal governments. A man who had designed the most produced fighter in history could not design a functional sewing machine. When West Germany joined NATO in 1955 and was permitted to rearm, Messerschmitt lost interest in microcars entirely. He sold the Regensburg factory to Fritz Fend and walked away from the automobile business without looking back. Messerschmitt left Germany. He moved to southern Spain and took a consulting contract with Hispano Aviation in Seville. There, he designed the HA-200, a jet trainer for the Spanish Air Force. It was the first jet-powered aircraft designed and built in Spain. He also worked on the HA-300, a lightweight supersonic interceptor intended for the Egyptian Air Force. The HA-300 flew but never entered production. Engine problems killed the program before it reached maturity. In 1958, the moratorium expired. Messerschmitt returned to Germany and resumed aircraft production. The company license-built the Italian Fiat G91 and later the American Lockheed F-104 Starfighter for the West German Luftwaffe. It was contract manufacturing, not original design. The company that had conceived the first operational jet fighter was now assembling another country's aircraft under license. In 1968, Messerschmitt AG merged with Bulco, a helicopter and missile manufacturer. The following year, the merged entity absorbed Blohm & Voss's aerospace division to form Messerschmitt Bulco Blohm, MBB. Messerschmitt was named honorary chairman. He was 70 years old. The company he had founded no longer bore his name alone. MBB would go on to build the Bo 105 helicopter, contribute to the Tornado multi-role combat aircraft, and develop components for the Ariane space launch vehicle. None of it carried the signature of lightweight construction that had defined every aircraft Messerschmitt ever drew. The philosophy had been absorbed into something larger, something collaborative, something fundamentally different from one man in an Augsburg drawing office deciding where the next gram could be removed. Willy Messerschmitt retired in 1970. He died on September 15, 1978 in Munich. He was 80 years old. His wife, Lily, had died 5 years earlier. He spent his final years in a city that had been bombed to rubble by aircraft his designs had failed to stop. The company he left behind continued to evolve through mergers, each one diluting the identity further. In 1989, MBB was absorbed by Deutsche Aerospace, DASA. DASA became part of Daimler Chrysler Aerospace. In 2000, that entity merged with Aerospatiale Matra of France and Construcciones Aeronáuticas of Spain to form the European Aeronautic Defence and Space Company, EADS. In 2014, EADS renamed itself Airbus Group. Today, the engineering lineage runs from a glider workshop in Bamberg to the largest commercial aircraft manufacturer in Europe. The factories in Augsburg that produced Bf-109s and Me-262s now produce structural components for Airbus airliners. The workforce that once riveted together fighter airframes using concentration camp labor now builds sections of the A320, the most commercially successful jet airliner in history. The name Messerschmitt survives inside this corporate architecture the way a foundation survives beneath a building that has been demolished and rebuilt 3 times. You cannot see it from the street, but the walls still rest on it. Jiro Horikoshi built the Zero by removing weight until the aircraft weighed less than physics seemed to permit. Grumman built the Hellcat by adding weight until the aircraft could absorb punishment no other fighter could survive. Messerschmitt occupied a position between the two philosophies and was consumed by forces neither designer had to face. The Bf-109 was a masterpiece of Leichtbau, a small, light, fast machine that won because it weighed less and flew faster than anything it met in 1936. It was still in production in 1945 because Germany had no industrial capacity to replace it with something better. The airframe that won the competition at Travemünde was the same airframe that was failing over Berlin 9 years later, bolted with heavier engines and heavier guns onto a structure that had never been designed to carry them. Messerschmitt's greatest fighter succeeded because of lightweight construction. It suffered because it could not escape lightweight construction. The narrow landing gear that saved weight killed pilots on the ground. The small fuel tanks that saved weight-limited range over England. The design philosophy that made the Bf-109 brilliant in 1936 made it obsolete by 1944. The Me-262 was the opposite. It was the future, arriving in a country that no longer had a present. It was an aircraft so advanced that it redefined what a fighter could do, yet it was produced by a regime that could not decide whether it wanted a bomber or a fighter. It was powered by engines that burned themselves out in 25 hours and built in factories that ran on the labor of prisoners who did not survive the year. The 262 did not fail because of engineering. The engineering was extraordinary. It failed because the political structure around it was incapable of making a rational decision and sustaining it. Messerschmitt gave Germany the weapon that could have altered the air war. Germany gave him the conditions that guaranteed it would not. The designer built the machine. The regime squandered it. And when the regime fell, the designer fell with it. Into prison, into sewing machines and bubble cars, into a decade of exile designing trainers for a Spanish dictator, and into a company that bore his name on a plaque inside a corporation that bore someone else's. Willy Messerschmitt built aircraft that changed the course of aviation. He built them for a regime that used slave labor to assemble them, a dictator who could not decide what to do with them, and a war machine that consumed them faster than they could be produced. The engineering survived every political failure. The man did not. The glider pilot from Bamberg, who set a world record at 23, who was bankrupted by a bureaucrat's grudge at 33, who built the most important fighter of the 1930s and the most revolutionary fighter of the 1940s, who served 2 years in prison for the labor practices of the factories that bore his name, who spent a decade building bubble cars and sewing machines because the Allies would not let him touch an airplane, who returned to aviation only to assemble other people's designs under license, and who watched his company merge and merge again until it disappeared into a consortium named after a city in France. That man died in Munich in 1978. He was 80 years old. He had built the future, and then he watched it taken away piece by every institution he had ever served. If this story changed the way you look at the machines that shaped our history, please subscribe and like the channel. We are excavating the legacy that time tried to bury. Help us build a deeper understanding of the past. The next chapter of history will be open soon.